Hello friends, welcome back to the channel. This is Divya Agarwal from Unacademy. So friends, as you know that in last lecture we have read about carbenes. Okay, we have, that was just an introductory video about carbenes. In this video, I'll be covering singlet carbene and triplet carbene individually. Okay, so stay tuned, and yes, if you are new to the channel, please kindly subscribe and like, and yes, share with your friends, because this year I am really dedicated to make daily videos for you all. Okay, so let's start. So guys, carbenes basically, carbenes can be subdivided into two portions. That is, one carbene is, singlet carbene, okay, and second is termed as triplet carbene, okay, singlet and triplet. Now, what is the difference between singlet carbene and triplet carbene? Just have a look. See. Now, if I write it like this, okay, R can be any species, R can be anything. I've written this, and triplet also, I'm writing it like this, okay. I will be writing two types of triplets, okay, and then I'll share with you that what is the difference between the two, okay. So just wait for a moment. So now these are carbenes. Now listen to me carefully, okay. So guys, basically see these spins. It is in one orbital, and in this I can put spins like this, right? Okay, and in this there can be two orbitals like this. Yes, okay. And in this also I can put electrons like this. Now we have to consider, we have to understand that what is the difference in this. Okay, so first of all you should know that this particular carbene also has an orbital, but this orbital is empty. This is pure p. First of all, consider this one is a pure p orbital. This orbital where there are electrons, so this particular orbital is hybridized. It is sp2 hybridized orbital. Similarly, if we just talk about these two orbitals, then these two orbitals are pure p. They are pure p orbitals. Fine, they are pure p. And if we just talk about this, then this particular one is pure p, and this particular orbital is sp2 hybridized. So this is the first point which you should know first of all. Okay. So now furthermore, if we just discuss that what is the difference, like how to deal with. So singlet, this particular one is termed as singlet. Why is it singlet? I'll just explain. Wait for a moment. But before this, you should know one thing, that the hybridization of this particular hybridization of this particular carbene is sp2. Okay, it is sp2. You can count sigma 1, sigma 2, and these are two electrons, so therefore it is counted as sigma. So we'll say that this is sp2 hybridized. Okay, similarly if we just talk about this one, okay, in this one, so basically this is sigma, and this particular orbital is sp2 hybridized, so we'll consider this also sigma, so therefore this is also sp2 hybridized. Fine. But if we just talk about this, then you can say this is sigma and this is sigma, but these two orbitals are they are pure p orbitals, so therefore hybridization of this particular carbene is sp. First point is to be noted, this point is to be noted. Okay, this is sp2, this is sp, and this is again sp2. Am I clear? This is sp2, this is sp, and this is sp2. So now what I'm saying is that this particular triplet carbene, okay, this particular triplet carbene is to be it is basically in rigid systems. It is basically in rigid systems. Now which type of rigid systems? We'll deal it with we'll deal about these in organometallic compounds. So let us just ignore it for a while, just ignore this type of hybridization for a while. So now just consider, like if you are if you are appearing for any competitive exam, and if they ask about that what is the hybridization of singlet carbene or triplet carbene in carbene, so basically it is considered to be sp2. So note this point. Okay, it is considered to be sp2 because this part where hybridization is sp is raremost. This is raremost. Okay, raremost, that too it is seen in organometallic compounds and in some coordination compounds as well. Okay, so this is raremost and is not it's not naturally, more of it's not known. So therefore we consider that singlet and triplet carbenes are sp2. This is the point one which is to be noted in this particular part. Okay, so I hope this part is clear to you all. So now I'll erase this and then we'll move further. Okay, so I hope and if you have any sort of query, okay, please comment down, so that at least I can explain you in the next video, okay, your queries. So I hope that part is very much clear to you all, and I always request you to make your own notes. Okay, so kindly it's always good to make your own notes. Don't use notes from other people. Okay, what you can do is you can read books and then prepare your own notes. You can watch videos, or you can watch your educators and prepare your own notes. Don't rely on the notes made by other people, okay, because it is their mind, it is their way of writing and their understanding. So never ever. This is just a suggestion. Okay, now singlet. How can we say singlet? Okay, why this particular carbene? If I write this carbene, why this particular carbene is singlet? Okay, why is it considered as singlet? So this is the point which we have to work on in this particular part. See, so now just listen. See, there is a formula, there is a spin quantum number. You must have read this quantum chemistry, right? S is equal to S1 plus S2. Now what is S? S is spin quantum number. This is spin quantum number. Fine, this is spin quantum number. So spin quantum number, see, this is considered as plus half and this is considered as minus half. Okay, this spin orientation is considered as minus half. So we will put it here. So plus half minus half, get out to, it gives 0. So it gives 0. And then similarly there is a formula that is SM. This is termed as spin multiplicity. Okay, this is spin multiplicity. Okay, so this spin multiplicity is equal to 2s plus 1. Fine, this is equal to 2s plus 1. So now 2s, what is the value of s here? It is 0 plus 1 equal to 0. So therefore it is concluded that the spin multiplicity came out to be 1. And as it is 1, so therefore we'll say that it is singlet. So I hope this part is very much clear to you all. I hope this part is very much clear to you all. Fine. Fine. Okay. Now listen one more thing. Okay, that I'll discuss afterwards. Abhi, let me erase this part. Okay. So Abhi, I am erasing this part. So I hope this part is very much clear to you all. If you have any query, please comment down. Okay. So that I can give you the suggestions. Okay. So now see what I'm saying. This is triplet. Okay. So this is triplet. Now we have to consider why that particular carbene is considered as triplet. So let us deal with it. So this is the diagram, okay, which represents triplet carbene. Fine. So now what I'm saying is, see, same formula we'll use. We have the formula S equal to, this is spin quantum number, S1 plus S2, spin 1 plus spin 2. So see, both are at the same level. See, they are upside. Okay. So let me use, either I can use plus half or I can use minus half as well. It does not make any difference. So ultimately it will give me the answer to be 1. Okay. So S, that is spin quantum number, came out to be 1. So we know spin multiplicity, formula for spin multiplicity is equal to 2 of S plus 1. Fine. So 2 of S, what is the value of S? It is 1 plus 1, that is equal to 3. Okay. So as spin multiplicity came out to be 3, therefore we say that this is triplet. This is triplet. I hope this part is very much clear to you all. So initial one, it was singlet. This one is triplet. So the difference is on the basis of the spin. Okay. Now third point. I hope this part is very much clear to you all. Fine. I hope this part is very much clear to you all. Now next point which we have to consider here is, guys, see, I have written singlet. Okay. And in singlet we can easily see, that we have this type of diagram. 2 electrons are mentioned like this. So we'll say that it is paired. We say that this is paired, and since it is paired, so we'll say that it will be ESR inactive. ESR, electron spin resonance, it is ESR inactive. Please note this point. It is ESR inactive and is also diamagnetic. It is diamagnetic. Fine. So please note this, that singlet carbenes are diamagnetic, it is paired, and it is ESR inactive, that is electron spin resonance inactive, or EPR also you can say, it's all up to you. Now let us write triplet carbene also, and let's see. So if we just talk about triplet carbene, so triplet carbene basically it looks like this, guys. It looks like this. Okay. So in this triplet carbene you can see this type of thing. Fine. Okay. Let me change the spin. Otherwise you'll get confused. Okay, so this is triplet carbene. Now as you can see that the spins are it's not paired, it's not paired, right? Since it is not paired, so we'll say that it is paramagnetic. Okay, and because it is paramagnetic, so obviously it will be ESR active. This is ESR active. So conclusion is that singlet carbenes are ESR inactive triplet carbenes are ESR active. Singlet carbenes are diamagnetic in nature, and triplet carbenes are, paramagnetic in nature. I hope this part is very much clear to you all. Okay, I hope this part is very much clear to you all. Now let's consider another point. Okay, I'm erasing this part. I hope this part is very much clear to you all. Now let us discuss about the bond angles. Okay, let us discuss about the bond angles in both. Okay, so see, singlet, I'll be writing it here. Now please look. This is singlet carbene, fine, and I'll be writing triplet carbene here. Okay, so this is triplet carbene. Now let us see. See, bond angle here is, it is approximately 100 to 110 approximately, and here the bond angle is, it is 130 to 150 degree. Okay, now the point is that why bond angle of triplet carbene greater than that of the singlet carbene region? What is the reason behind? Okay, so you must be knowing one thing. You must be, if you have read chemical bonding, you must have read one point according to VSEPR. VSEPR used to say, what is VSEPR? Valence shell electron pair repulsion theory. It used to say that the lone pair repulsion is most, then we have lone pair single bond pair repulsion, then we have single bond pair and single bond pair repulsion, then after this we have single bond pair and radical repulsion. Okay, single bond pair and radical repulsion. So this conclude that lone pair repulsion is most. So since the lone pair repulsion is most, so the molecule will move, atoms will move farther from each other. This is second, this is third priority, and this is fourth priority. So now please have a look. See, these are lone pairs. This is lone pair bond pair repulsion. Fine, this is lone pair single bond pair repulsion. It is greater than bond pair. See, single bond pair. This is smaller. This is small repulsion. This is more repulsion. So just because at this point there is more repulsion, so we'll say that this will be squeezed, R1 and R2 will be squeezed, and therefore the bond angle is 110 to 100 to 110. This is the range of bond angle in singlet carbene. But if we just talk about triplet carbene, so in triplet carbene, what is the difference? Why this bond angle came out to be greater? So please have a look. This particular, this is single bond pair, and this is radical. See this is a radical, isn't it? This is radical, this is single bond pair, and these two are single bond pairs. And we can see single bond pair repulsion is greater than that of this. So now at this point, repulsion between this R1 and R2 is greater than that of this R and this radical. So therefore this R1 R2 gets elongated, or you can say it will be the bond angle will get increased. So this is the reason behind that why bond angle of triplet is greater than that of the singlet. So I hope this bond angle concept is clear to you all. If you have any query, any doubt, please do let me know. Okay, now this this bond angle is not a theoretical concept. It cannot be seen like if I say that yeah, this is 110, it is 130. Basically it is seen in using spectroscopical techniques like crystallography, like NMRs, like many more spectroscopical techniques can be used to find out the bond angle. Okay, so don't think that this is a theoretical concept, that this is just theoretically I've explained that why bond angle at triplet carbene is greater than that of the singlet carbene. But in reality this is not a theory. This is a crystallographic technique through which we come to know that bond angle of triplet is greater than that of the singlet. So this is the point which you should always work on. Fine. So guys, thank you so much for being with me. We'll meet you tomorrow again at the same time. Okay, and yes, if you are new to the channel, kindly subscribe, and yes, share with your friends so that everyone can get benefit and our channel can grow. Okay, thank you so much for being with me. Tata, see you, take care.